So 3D printing is the latest and the most uh, versatile form of manufacturing available at the hands of a common man. With the help of 3D printing, gone are the days when you had to make uh, molds, okay, molds specific to your designs. But now with the help of 3D printing, you can do all sorts of designs without the use of molds. This 3D printer works by layering the filaments of plastic which are in their molten states, one on top of the other, in such a way that the end product resembles your design. If I speak about the software, um, I wouldn't know much. But if I had to speak about just basic parts of the 3D printer, there would be one is the bed, one more is the nozzle, one more is your user interface panel, and the filament. The bed is a base from which your 3D print starts to build. The nozzle is obviously the one which takes in the filament and converts it into a plastic fluid, and then you have the filament itself, and then you have the user interface panel. The user interface panel is not necessary to be present in all printers because some printers have the option of directly communicating with your PC. In my case it was not the same, because in my case I had to have an SD card, uh, which would be placed inside the printer, and I had to select my files within that interface and click print. That's how it's work, but not necessary to be present in all other printers. So yeah, these are the some of the things which you must know before we move further into the video, and I hope now we have some basic understanding about what a 3D printer is, what 3D printing is, and how it works, and some related stuff. So let's get into the video now. Okay. The first mistake which I would like you guys to avoid is that of setting the bed temperature and the nozzle temperature. The nozzle temperature is a no-brainer because obviously you need the nozzle hot enough to melt the filament into the plastic fluid, right? The temperature which we usually place it is around 200 degrees Celsius, and anything more than 200 degrees Celsius would be a waste of energy, and anything less than that, your filament won't be able to properly convert into the plastic fluid which we want for the 3D printing. The real stuff comes down when you are talking about the bed temperature. Now, why is this bed temperature important? Let me help you understand the example. If you have a bed which is at normal temperature and you start printing on it, the first layer which falls on the bed cools off immediately due to convection. And once a print is done and you're trying to remove this print off the surface, what what happens is that a portion of your model gets remains stuck on the surface of the bed. It won't come off easily, and this is undesirable because first of all, you wouldn't want your model to be half complete, right? Because half portion is already half portion is already sticking on your bed, which is problematic itself, and we don't want that. So the solution for this was to heat up the bed. Okay, when you heat up the bed, there is sufficient time for the uh, material which is deposited on the bed to cool down. Earlier it was the duration was short. Now since the bed is at a higher temperature, you can expect it to stay in that molten state for a long duration of time, and and this duration is usually long enough until the next layer of the film the plastic layer comes up, and this helps in better adhesion between the two layers. And finally, when the print is done, you are able to properly remove the part without having any sort of breakage between the in between the prints, and not having any part of the print remaining on the bed. So yeah, this was about the temperature settings. The next thing which I want you guys to be read about is that of infill. Okay, for those of you who don't know infill, infill is basically how dense you want your 3D print to be. Lower amounts of infill, like 10 to 20%, will reduce your printing time, will reduce the amount of PLA that goes, or the material which goes into your print. But then you will have 3D prints which are more susceptible to breaking when force is applied. If you are moving towards higher levels of infills, like more than 50%, then you'll end up with very sturdy, very rigid prints. But the downside is that you'll use a larger amount of your filament, and there'll be a greater print time. So, what is your takeaway from this? Should you guys do like higher infill, or should you guys take go up for lower infill? Well, in my opinion, it depends on the application you're trying to build the 3D print for. If say the 3D print is gonna be, just for the showcase purpose or for representational purpose only, I suggest you go with lower infills, because either is you are not gonna subject it to heavy stresses, so it's just gonna stay there as a piece of show. That's the most logical use of your time and the filament as well. If you're doing a 3D print which is supposed to be subjected to heavy levels of stresses, then I suggest you go with higher infills. And by higher infills, I mean you don't have to go close to 100%. Can anything greater than 50% will do good. The third point which I want you guys to be aware of is that of the print speed. As you know, 3D printing is a very time consuming process, but nowadays most of the printers come with the option to slightly increase your print speed. But there is a downfall to it, and that is lower quality prints. Let me tell you how this occurs. Usually, what happens is that once one layer of plastic gets deposited, it there is sufficient time for the plastic to solidify until the next layer of print comes, until the next layer of plastic comes over and is placed on it. And this is how the building process usually occurs. But if you increase the speed of the print, what happens is that these plastic layers do not get enough time to solidify, and when the next layer comes over, they are slightly squashed. These minor defects are not noticeable during the print, but once you remove the print and you start examining them, or say you are about to use this print in some low clearance kind of parts. Like in my case, I was printing a part which a portion of which had threads on it. Okay, and me being the impatient guy as I am, I increases the print speed, and yeah, I ended up with a quick print. But when I tried to mesh those threads with a matching part, I wasn't able to fit it in. At the end, I had to muscle through and rub the two pieces against each other, hoping that the friction will smoothen out the teeth, and that way they'll mesh. This was totally unnecessary, because I could have totally resolved this issue if I had gone with the normal print speed, but I didn't. And that's what I want you guys to avoid. If you're trying to, print parts which are supposed to mesh with other parts, make sure that you go with lower prints. But is it necessary that you always go with lower print speed? I know that at times we are in a rush, so we will need to increase the print speed. But when one rule of thumb is that if you are printing, if a portion of your print has some basic shape, like say it's trying to print a like pyramid, a portion of it consists of a pyramid, portion of it consists of a cylinder, or some other basic shapes, go with faster prints. Okay, uh, these uh, these shapes by themselves are strong, and I don't think that increasing the print speed will have any effect on their structural strength. But when it comes to very precise parts, okay, very precise portions of your 3D prints, like the threads which I just mentioned, make sure you decrease the speed then, so that way you don't end up having, these defective teeth, and cause you which might cause you problems later down the line. So yeah, these please avoid those kinds of issues. And that's it. Thank you for watching this video. If you like this video, you know what to do. You know the basic drill: like, share, subscribe, all those stuff. Do it. And yeah, I hope I'll be able to create more such of these kinds of videos later in the future. I am actually trying to, but then let's see how it turns. Okay, because I need my peace of mind as well. And yeah, see ya. Bye.